Hello students, today we are going to continue with Kirchhoff's law part 2. So today we'll be discussing 3 questions. So our first question will be this class 12 CBSE 2025 question number 17 of set A, question number of 21 from set 2 and set 3. So this is the question. This is based on Kirchhoff's law. The question reads like this. In the circuit, 3 ideal cell of EMF V, V and 2V are connected to resistor of resistance R, a capacitor of capacitance C and another resistor of resistance 2R as shown in the figure. In the steady state, find first is the potential difference between point P and Q, and second is potential difference across the capacitor. So here you see in this figure, as you can see the figure very clearly, when steady state is reached, that means initially current is flowing through this part and as a result the capacitor is getting charged, and when the capacitor is fully charged then it blocks the current and as a result no current flows through this part, and therefore you can consider this as a single loop and a same current flows through this loop, and that is what I have written here. See, when steady state is reached, the capacitor gets fully charged and no current flows through the segment PQ, and same current flows to the remaining part of the loop. That means I am speaking about this loop. Same current is flowing through this part of the loop. Okay, so we'll continue this. हाँ, तो जैसे हम बोले कि इस पार्ट में कोई करंट फ्लो नहीं करेगा, अगर इस पार्ट में कोई करंट नहीं फ्लो करता तो हम लोग के पास एक ही बड़ा सा लूप है जिसमें करंट फ्लो करेगा. अगर इसमें करंट फ्लो करता है, एक ही लूप है, तो इसमें करंट will remain the same. So for a part में current will remain the same. अब करंट का डायरेक्शन इज टोटल योर चॉइस. कैसे लीजिए तो हम इधर लिए. दिस इज द डायरेक्शन ऑफ करंट आई हैव टेकन. यू कैन टेक द रिवर्स वे आल्सो, बट यू शुड अप्लाई द लॉ अकॉर्डिंगली. तो हम यहां पर करंट का डायरेक्शन ऐसे लिए हैं. अब करंट का वैल्यू हम लोग को निकालना पड़ेगा V एंड R का टर्म्स में. इसीलिए हम किरचॉफ्स लूप रूल लेंगे ओवर दिस बिग लूप A, B, Q, C, D, P, A, as I have written here. So first of all, we are going in this direction. अगर इधर जा रहे हैं तो माइनस से प्लस जा रहे हैं तो प्लस V. यहाँ पर अगेंस्ट द डायरेक्शन ऑफ करंट जा रहे हैं तो प्लस IR. फिर यहाँ पर we are also moving against the direction of the current, so plus 2IR. यहाँ पर नेगेटिव पॉजिटिव से नेगेटिव जा रहे इसलिए माइनस 2V. Back to the same point to 0. Now this can be simplified further. This is V and this is minus 2V becomes minus V. This is IR. This is plus 2IR becomes 3IR is equal to 0. Therefore V becomes equal to 3IR and therefore I is equal to V by 3R. So ये हमारा करंट का वैल्यू हुआ in terms of V and R. First part of the question says find the potential difference between point P and Q. P and Q का बीच का potential difference निकालना है. और ये P and Q का बीच का potential difference निकालने के लिए हम लोग किरचॉफ्स रूल अप्लाई करेंगे from point P to Q along the path P A B Q. ये कैसे अप्लाई करते हैं इसके लिए हम लोग प्रीवियसली एक क्वेश्चन किए थे, उसको थोड़ा देख लीजिए. As I explained you previously, in order to find the potential difference between A and B in this type of circuit, we'll be applying Kirchhoff's law along this path. So potential at this point is VA. We are moving along the direction of the current, so the product of current and resistance is minus 2 into 2. Here you are moving from positive to negative, so minus 3. Here we are moving along the direction of current, so minus 2 into 1 is equal to, and we coming to this point, so is equal to VB. Therefore VA minus 4 minus 3 minus 2 is equal to VB. and therefore VA minus 9 is equal to VB, and therefore VA minus VB is equal to 9 volt. होपफुली आप लोग समझ गए कैसे लगाया जाएगा। तो ए पी ए बी क्यू में हम किरचॉफ्स लॉ को लगाएंगे along this path. So potential at this point VP, you are going along this direction, so it is plus V. You are going along against the direction of the current, so plus IR to this point is equal to potential at this point. तो दिस इक्वेशन आ गया। यहां से हम लोग लिखेंगे Vp, इसको इधर लाएंगे माइनस VQ, ये दोनों को इधर ले जाएंगे माइनस V माइनस IR। सो माइनस V माइनस I का वैल्यू इज दिस, R का वैल्यू पुट कीजिए तो माइनस V by 3। इसको जब सिंप्लीफाई कीजिएगा इट विल कम Vp माइनस VQ इज इक्वल टू माइनस 4 by 3। So Vp minus VQ becomes minus 4V by 3. So and this is the potential difference between these 2 points. So हम लोग का first part of the question solve हो गया। Second part of the question कह रहा find the potential difference across the capacitor. So when the steady state is reached, the capacitor is charged, and when this capacitor is fully charged, it blocks the current. So I told no current is flowing along this path. Just because these two plates are charged, there will be a potential difference across the capacitor, and we have to find that potential difference across the capacitor in the next part of this question. So we'll apply loop rule along the loop A, B, Q, P, A. Along this loop, we'll apply the loop rule. So let's see. First of all, we are going along this direction from negative to positive, so plus V. Here against the direction of the current, so it is plus IR. Here we are moving in this direction, so potential difference across the capacitor VC. Here we are moving along this direction from positive to negative, so minus V. Back to the same point is equal to 0. ये equation हो गया। इस equation से you can see that V and minus V cancel हो जाएगा, therefore VC becomes equal to, इसको इधर ले जाएंगे minus IR। I का वैल्यू यहां से पुट कीजिए तो माइनस V by 3R into R becomes minus V by 3. Therefore, potential difference across the capacitor becomes minus V by 3, and that is how we have solved the second part of the question. As many of you have said, this was a very difficult question. No, this is not at all difficult. If you simply follow the Kirchhoff's law properly, you can solve it. तो हम लोग का दूसरा क्वेश्चन है, see, इस क्वेश्चन में we have to find the value of I, E1, E2, R. This is I, E1, E2, and this R has to be found out. हम लोग यहाँ पर किरचॉफ्स लॉ लगा के इजीली इसको सॉल्व कर लेंगे। देखिए कोई दिक्कत होने वाला नहीं है। फर्स्ट ऑफ ऑल we'll find this current I. For that, Kirchhoff's point rule has to be applied. So if you apply point rule at point E, you will be applying point rule at point E. This current 3 ampere is approaching the point, 5 ampere is approaching the point, and I is moving away from the point. So if we apply, it becomes 3 plus 5 minus I is equal to 0. Therefore, I is equal to 8 ampere. So this current will going to be 8 ampere. So we can write here, this is 8 ampere. I is equal to 8 ampere. Next, we'll be solving for this E1. E1 के लिए solve करना है। E1 के लिए solve करेंगे तो हम लोग this loop को लेंगे। This loop G H E F G. So applying loop rule to the loop G H E F G, we'll have first of all we are moving along this direction from positive to negative terminal, therefore minus E1. Here we are moving against the direction of current, so the product 3 into 8 with positive sign, so 3 into 8. Here again we are moving against the direction of the current, so product 4 into 3 with positive sign. So this minus E1 plus 24 plus 12 is equal to 0. And therefore minus E1 is equal to minus 36, and therefore E1 is equal to 36 volt. तो E1 हम लोग का 36 volt हो जाएगा. So we can write this E1 now 36 volt. Now we'll be solving for this E2. In order to solve for this E2, हम लोग को Kirchhoff's loop rule लगाना है for this loop, that is H C D E H. इस loop में Kirchhoff's loop rule लगाएंगे. So that is what H C D H. Now पहले हम लोग मूव करेंगे along this direction. We are moving from negative to positive, therefore plus E2. Here we are moving along the direction of the current, so this product will be minus sign, so minus 6 into 5. Here again we are moving along the direction of the current, so minus 3 into 8. Back to the same point is 0. Therefore plus E2 minus 30 minus 24 is 0, and therefore E2 is equal to 54 volt. E2 becomes 54 volt. So we can write this as 54 volt. Lastly, we have to solve for this R. This R has to be found out. So again we'll apply loop rule to the loop A, B, C, H, G, H. In this loop we'll apply the loop rule. So first of all, you are moving against the direction of the current. So this is plus 2R. Then here we are moving from positive to negative. So minus E2. Here we are moving from negative to positive. So plus E1. Back to the same point is 0. So 2R. E2 is minus 54. E1 is 36 is equal to 0. So 2R minus 18 is 0. Therefore 2R is equal to 18 and R is equal to 18 by 2, that is 9 ohm. Therefore we get R as 9 ohm. So this is how we have solved for I, E1, E2 and R. Hopefully you have understood this question. Yes. Our next question is, find the equivalent resistance between point A and F in this diagram. So this is A and this is F. You have to find the equivalent resistance between point A and F. Now each one of this wire has a resistance of R, small r. Here, in order to solve the equivalent resistance between A and F, we'll apply Kirchhoff's law. And in order to apply Kirchhoff's law, there should be some current in the circuit. Without current, you cannot apply the Kirchhoff's law. So we have to take the current. So how can I get current? For that, I'll apply a source of current between point A and F. So I'm modifying this diagram slightly by considering a source of current between point A and F. So this is the source of current between point A and F. So this modification I have done. This E will send a current in this circuit. Now what should be that current? What should be that current? I'll consider here the current as 6I. Your obvious question will be why 6I and not I? I'll try to explain this, why it is 6I. See, here it is getting equivalent 3 parts. So naturally this will get equally divided between these 3 parts as 2I. Here also it is 2I. Here also it is 2I. This 2I will get equally divided as I and I. This here, this 2I, see this 2I will get equally divided as I and I. Got it? And this 2I will get divided equally as I and I. Got it? So you can see that this current and this current will come and get as 2I. Now this current and this current will get added up as 2I. This current and this current, see here, this current and this current will get 2I. So this is coming as 2I. This is coming as 2I. This is coming as 2I, and again it becomes 6I. So that is the reason that I made it current as 6I. Had I taken it as I, then this would have been I by 2, this would have been I by 3, I by 3, I by 3, this would have been I by 6, I by 6 likewise. So in order to avoid fraction, I've taken it as 6i. So now we'll apply the loop rule and try to solve it in a very simple way. हाँ, जैसे इस डायग्राम को मॉडिफाई कर दिए हैं, मॉडिफाई करके बिटवीन पॉइंट ए और एफ का बीच एक battery of EMF is being inserted, and this battery obviously will send some current to this circuit, and I have considered the current to be 6i, and this 6i will get equally divided among these three parts as 2i through this, 2i through this, 2i through this. This 2i again will get divided as I and I. This 2i will get divided as I and I, and this 2i will get divided as I and I. Now this 2 current will meet and become 2i, this 2 current will meet and become 2i, and similarly this 2 current will meet and becomes 2i, and again when they come here it becomes 6i. So this is what has been modified in this diagram. Now we're going to apply Kirchhoff's loop rule over the loop. As you can see, that is A, B, G, F, F, J, K, L, M, A. Got it? So along this path, Kirchhoff's loop rule will be applied. So first of all, you are going along the direction of the current, so it is minus 2IR. Then again you are moving along the direction of the current, so the potential drop minus IR. Here again you are moving along the direction of the current, so this is minus 2IR. Then it is coming like this, from negative to positive terminal plus E, back to the same point, it is 0. If I add this and this, it becomes minus 5R, and I'll take E to the other side. So when I take E to the other side, it becomes minus E, minus minus gets cancelled, and therefore E becomes equal to 5IR. This is the first equation. Next, I'll consider the equivalent resistance between A and F as R. If the equivalent resistance between A and F is capital R, then this whole diagram can be redrawn as between A and F it is capital R, and the remaining part, this remaining part remains the same. So between A and F you have the EMF E and current is 6I. Okay, so we have considered the equivalent resistance between A and F as capital R. So from Ohm's law, E is equal to 6I into R. This is equation 2. And if I equate equation E, this 1 and 2, it becomes 6IR is equal to 5I small r. I gets cancelled, and therefore capital R is equal to 5 by 6 small r. This is how you get it. And if I consider small r as 1 ohm, that means each one of them as 1 ohm, then capital R equivalent resistance between A and F becomes equal to 5 by 6 ohm, and that is the answer. So this is how you can solve. Here you need to consider an external EMF which will be delivering 6 ampere current, which is equally getting divided, again equally getting divided, again equally divided, and they are recombining to become 6 ampere 6I, and this is how you can solve this question. Hopefully you have understood this.